Hello friends, let's do some more limits. Let's consider a limit x towards 0 of x to the power of x. The trick here is to rewrite it as x running towards 0 as e to the power of ln of x to the power of x. Now we're going to get limit x towards 0 e to the power of x times ln of x, and now basically it's all about this value, and we've been doing it. Let me remind you, this is L'Hopital's rule, so x towards 0, x times ln of x. It's not directly the case for L'Hopital yet, but if we are rewriting it as ln of x divided over 1 divided by x, now it is the case for L'Hopital. So that means we're going to get 1 divided by x here and minus 1 divided by x squared there. Now we can move on. We are going to get a limit x towards 0. We multiply times the reciprocal. So this is 1 divided by x. I'm putting minus in front. X squared divided by 1. So basically this is x. So minus limit x towards 0 of x, which is of course 0. What does it mean? Well, that means that this value is approaching 0 and the total value is e to the power of 0, which is perfectly 1. So limit of x to the power of x is 1. This is really important. I mean, we proved it, and this is um, telling you that 0 to the power of 0 is also 1. Not obvious. Okay, next one. Let's consider limit x towards plus infinity of x to the power of 1 divided by x. Once again, kind of the same trick. We are going to rewrite it as e to the power of ln x to the power of 1 divided by x. We bring it up. We bring it in front, sorry. We got the limit x towards infinity e and to the power of ln of x divided by x. And now you see there is a battle between those two. Who gonna win? Both are running towards infinity. What about the pace? Well, let's use L'Hopital again. It tells us it's a limit x towards infinity. 1 divided by x is the derivative of ln, and 1 is the derivative of x. If x is running towards infinity, this guy is going to be 0, so the total result is 0. So once again, if x runs towards plus infinity, this value is e to the power of 0, which is 1 again. This is the second one. And, well, let's do maybe the third. Which one is nice? I don't know. Let's maybe do this one. Limit x towards 0. I think it's 3. I cannot read it exactly here. This Demidovich book. Okay, is that correct? No, it's not. Sorry. It would be a very easy limit to handle. This is x to the power of 3 divided by 4 plus ln of x. I'm not sure 3 and 4 have any kind of special meaning here, but well, let's see. So the problem is ln is approaching minus infinity. So we are dividing 3 by huge negative numbers, so this is going to 0. So it's 0 to the power of 0, which should be 1. Let's see whether it's true. I mean, don't see I have to use L'Hopital somehow. Well, let's rewrite it maybe. Let's see. So this is a limit x towards, assuming of course I wrote the question correctly, but I hope that's the case. So x to the power of 3 divided by 4 plus ln x. We bring this guy in front. So basically it's about limit x towards 0. We have, well, yeah. We have 3 ln x divided by 4 plus ln x. All right. Now these are in both cases minus infinities. So let's use L'Hopital. Now we can do it. This is 3 divided by x. And this is minus 1 divided by x. Sorry, just plus 1 divided by x. So this is 3. Doesn't matter what x is doing. Well, that's kind of nice. I'm surprised myself. I thought it should be 0 to the power of 0, which is 1. It's not. So this, the whole exponent is going to be 3. So this is e to the power of 3. I like it. Okay, thanks for watching. See you in the next video.